Hmm. So, a very good afternoon, everyone. Sorry for the delay because of some network error, network issue. The class was being delayed. So, I welcome you all for the Strength of Materials lecture series with the code 18CV32. So, to have a brief brush up, in the previous session, we had studied numerical examples on torsion. That is basically we have derived the torsional equation, and then we had proceeded for the numerical examples, that is to determine the diameter of the shaft based on shear stress criteria as well as based on angle of twist criteria, right? So whichever was the maximum diameter that we have chosen as the minimum diameter to be used for the design of the shaft, right? So let's continue these numerical examples in today's session. Let's continue these numerical examples in today's session. So I hope this PDF is visible to you. Right. So yesterday we have seen this numerical example, right? So today we shall see about the hollow circular shaft. Right. So please observe this question. So basically, before I start with the question, we know that 1 watt, okay? So watt is unit to measure the power. 1 watt is nothing but 10 raised to 3 Newton meter per second, right? So 1 watt is nothing but basically 1 watt is nothing but Newton meter per second. If you want to convert this watt in mm, then you need to multiply 10 raised to 3. All right. So to read this question, a hollow cylindrical shaft is 200 external diameter and with the thickness of the metal as 25 So basically you have a hollow cylindrical shaft whose external diameter is 200 and the thickness of the shaft is 25 Okay. And it is transmitting power of around 200 RPM. Okay. It is transmitting power at the rate of 200 RPM. And the angle of twist over the length of 2 meter was found to be 0.5 degrees. So angle of twist is 0.5 degrees and the length of the shaft is 2 meter. Now he is asking you to calculate the power transmitted and maximum shear stress that is induced in the section. Okay, and take modulus of rigidity of the material as 84 kilonewton per square. Right, so this is a given question. So you can see here I have drawn the cross-sectional area, okay, circular hollow circle, wherein it is clearly shown D1 is the external diameter, which is equal to 200 and thickness of the shaft is 25 and from this you can easily determine the D2 value, that is the diameter of the internal circle, that is D2 is D1 minus 2 into T, so 200 minus 2 into 25, that is 150 Okay, now after this, go on writing the given conditions, that is N RPM is 200 RPM, theta angle of twist is 0.5 degrees, convert it in radians, that is 0.5 into pi by 180, length of the shaft is 2 meter, so I have taken it in 2000 and G is equal to 84. It was kilonewton per square. So I've converted in Newton per square. That is 10 raised to 3 Newton per square. Okay. Now, since it is hollow shaft, use the proper J formula. That is polar moment of inertia. J is pi by 32 d1 raised to 4 minus d2 raised to 4. So substitute these values and operate the calculator properly. You're gonna get 1.0737 into 10 raised to 8 raised to 4. Make sure you write the units compulsorily. Now, by using the relation, that is T by J is equal to G theta by L. So you know the torsional equation now. From the torsional equation, since G and theta L is known to me, I can use this relation to find out the torque T. right? So T by J is equal to G theta by L. Take the T outside because T, that's what you're going to find out. Okay, from once I get the T value, then I can use it in my power equation. So substitute this. After substituting carefully, see, make sure that L should be in mm and theta should be in radians. Okay, now you're going to get the torque value for this particular problem as 39.356 into 10 raised to 6 Newton mm. Okay, and power P is 2 pi nt by 60. We know this formula. Substitute the T value, whatever you have got. So now the power which has been calculated here is 824.27 10 raised to 6 Newton mm per second. Because everything you have calculated in mm, right? So it is Newton mm per second. If you want to get in watt, okay, what is watt? Watt is nothing but Newton meter per second. So you have 10 raised to 6, 10 raised to 3, you can use it for kilo, 10 raised to 3, you can use it to convert mm to meter. So basically, I can write 824.27 kilowatt as power. This is what has been asked to you. Of course, he has asked you another quantity to determine, that is maximum shear stress. So now for the shear stress, you have the relation Qs by R is equal to G theta by L. Of course, you can also use T by J is equal to Qs by R. That is also well and good. Okay. So in both both the equation, you're going to get the same answer. So use any relation you want. So in this state, Qs outside, you will get Gr theta by L. So substitute this G. What is R? R is the V1 divided by 2. That is external diameter divided by 2. Right? So substitute it radius d by 2, 0.5 into 5 by 180 into 1 by 2000. So you're going to get maximum shear stress as 36.652 Newton per mm square. So let's see the next problem. A shaft is required to transmit 245 kilowatt power at 250 RPM. Okay. Now the maximum torque may be 1.5 times the mean torque. The shear stress in the shaft should not exceed 40 Newton per mm square and the twist 1 degree per meter length. Determine diameter required if shaft is solid, and the second case, shaft is hollow with external diameter twice the internal diameter. And he is asking you take modulus of rigidity or shear modulus capital G as 80 kilonewton per mm square. So in this particular problem, first go on writing what are the given conditions. So given is power P 245 kilowatt. So convert this in Newton mm per second. Next, N is 240 RPM. And he has given you maximum torque. See, if it is simply mentioned as torque, then you would have taken T. Now he has mentioned that maximum torque is 1.5 times the mean torque. So T max is equal to 1.5 times the mean torque. You can write it as T mean. Okay. So QS is 40 Newton per mm square. G is given. Theta is given. L is 1 meter. That is 1000 mm. Now write down the power equation. T is equal to 2 pi nt by 60. So substitute this T value and T as it is. Keep it. Okay. Now you're going to find out T from this particular equation. In the previous problem, it was exactly reversed. Now, from the power equation, I am calculating torque. So, whatever you calculate torque, this will be considered as mean torque. This mean torque, from the above equation, you can calculate the maximum torque. So, that's what I have done here. T mean is this value. And maximum torque will be 1.5 times the mean torque. So, calculate T maximum, that is 14.623 into 10 raised to 6 Newton mm. Now, everywhere you're going to use the maximum torque equation. Okay. Now, there are two cases. Let me see the first case for solid shaft. So, for solid shaft, what is the J value? It is pi by 32 d raised to 4. So, first find out the diameter with the help of first criteria, that is shear stress criteria. That is T by J is equal to Qs by R. R is D by T. Okay. Now, in this, take this T outside. Okay. So, T is equal to pi by 32 d raised to 4. Why pi by 32 d raised to 4? Because it is J value, polar moment of inertia. Okay. So, into Qs by D by T. So, operate this, simplify this. Okay. When you simplify, you're going to get the diameter. You will get, in terms of cubic equation, Okay, that is cubic value you will get. So when you take a cube root, then you are going to get 123.02 mm. What is this? This is a diameter based on shear stress criteria for the solid shaft. But this is not the end of the story. You are going to calculate another diameter with the help of another criteria, that is angle of twist. So take the angle of twist relation. Tmax by J is equal to G theta by L. Take this Tmax outside, okay, and substitute all these values which you have written in the given condition, and you're going to get the diameter for a solid shaft as 101.628 mm. Okay, now which value should be chosen for the solid shaft? Whether it is 101.628 or 123.02, which will you choose? You should choose the maximum value. That maximum value should be considered as the minimum diameter that has to be used for the design. Okay, so that's what I have written here. Maximum value, use a minimum of 123.02 mm as the diameter. Minimum means minimum for the design purpose. Okay, now come back to this case 2, that is hollow shaft. In case of hollow shaft, let's assume that D1 is the outer diameter, D2 is the inner diameter. Now, it has been given in the question already. Given the diameter is 0.5 times the external diameter, or it is 50% of the external diameter, so D2 is 0.5 D1. Use this relation. First of all, write the J value, that is 5 by 32, D1 raised to 4 minus 0.5 D2 raised to 4. Okay, now J is equal to 0.092038 D1 raised to 4. So what you do in this equation is take D1 raised to 4 as common, you will get 1 minus 0.5 raised to 4. So when you operate in calculators, 1 minus 0.5 raised to 4, you are going to get this value and just multiply it by 5 by 32. So you will get 0.092038 D1 raised to 4. Okay, now from shear stress consideration, so as I have already stated, you should consider two criteria. One is shear stress criteria and one is angle of twist criteria. Same thing you can do this here. So first shear stress criteria, Tmax by J is equal to Qs by D1 by 2. So substitute all these values, operate the calculators properly, cross multiply, you're gonna get D1 as 125.696 mm. And see, when you operate this actually, when you cross multiply it properly, you will get an equation in terms of D1 cube. So take the cube root and you will get 125.696 mm. Okay. Why D1 cube? Because you can see here, this D1 and this D1 will get cancelled. So what? It will get an equation in the form of D1 cube. Now from the angle of twist criteria, Tmax by J is equal to G theta by L. So substitute all these values, you're gonna get D1 as 103.281 mm. So now once again, check which is the higher value, whether okay, here D1 is 125, here D1 is 103, which is highest value 125. So 125 mm should be chosen as the minimum diameter that has to be used for the design. So D1 is 125.696 mm. Once if you have the D1 value, you can get the D2 value, that is 0.5 D1. Multiply this, you will get D2 as 62.848 mm. So now these values can be used for the design purpose. Okay. So that's all. So you can take, we have today in this particular class, we have solved these two examples. In the next class, we shall see another example related to the percentage saving of the area. Okay. And before that, before we meet in the next class, I want everyone to solve this equation, to solve this numerical example, that is true that hollow shaft is stronger and thicker than the solid shaft of same material, same length and same weight. Okay, so give a try for this. If you face any difficulty, we will continue in the next class. Okay, so two examples are remaining. This we shall continue in the next class. Okay, so that's all for this today's session. Thank you.